Okay, so finally, here we go. We've had this problem up in the office for, I don't know, for a while. I'm going to say almost a month. It has gone unsolved. Can we finally solve this thing? It has stumped many kids. We're going to retire it, we're going to solve it here, and then we are going to post another one. So let's see what we got here. And by now everyone's probably seen the problem. You know, we've got a rectangle. It says it's a rectangle. The area is 70. We got a bunch of little triangles in there, and we need to find the area rather of this little sucker in there. So, you know, let's use what's given first and foremost, and let's try and get some relationships. Because as you know, as you think here, I mean, there have been kids that have tried to put this into the coordinate plane, which is not a terrible idea. Actually, quite a good idea. But we're just going to solve it using similar triangles because that is more. You know, those kinds of concepts will come up more on the SAT and the ACT, so it's good to see it more in action. So let's look at it. We know that DE equals EC, so at the top there, and I'm just going to label those, I'm just going to get some relationships there. I'm just going to label that X. So those are X. And we know that these three pieces are the same, so I'm just going to label those Y. They're all the same. And one relationship we have, right, because it's a rectangle, obviously the two sides are the same. One relationship we have is that 2x is equal to 3y. You know, and if you want to solve for x, you could say x is 3 halves y. If you want to solve for y, you could say y is 2/3 x. So we have relationships there. And one thing we also know is that they both share this in common. I guess we'll call this the height, h. They share that in common. We don't know what that is, but what we do know, right, is that the length times the height, either 3y times h or 2x times h, we know that that's 70, right? That's a fact because the area is just 70. So I'm going to say 3y times h is 70. And if I solve that, I'm just going to try to get some sort of relationship between y and h here. I'm just going to say y times the height is 70 over 3. So maybe we can use that. We'll have to see here. So as I've said, similar triangles, right? We should know what those are. Those are just triangles that have all three angles are the same, so therefore all the sides are proportional. And a good way to look at this one when trying to figure out which triangles are similar, a lot of times look for vertical angles because, right, we know that vertical angles are congruent and that will give us one angle that, you know, a pair of angles that are the same, so then we can sort of try to go from there. And when I look at this, if I look at, let's say this triangle here, triangle AHF, right, I think that's similar if we look at this big one here, EHC. So let's see what we can do with that here. Are those similar? Well, they're going to share that vertical angle, right? So those angles are the same. You can see we have a diagonal going through the rectangle, and a rectangle, right, all those angles are 90. This is going to be 45 here, which would make that one 45. So now we have two angles that are the same, which just must mean this angle here and this angle here have to be the same. So these two triangles are similar. Well, let's see what we can do with that. I mean, if we were going to try to get the area of this thing, right, we would know of AHF, we know it's 1/2 times the base, which looks like it's just y, times the height, which we don't really know yet. Like, it's just this little piece. I'm just going to leave that. And I know that the area of this bigger one, EHC, is 1/2. And I know the base here is x, but what I'm going to try to do is get everything into one variable. So I'm going to use my relationship here, that x is equal to 3/2 y. So just erase that there. So instead of x, I'm just going to say it's 3/2 y. Now I look at it, so I can see the height. I don't really know what's going on. I just know that the two heights combined have to add up to h, right? Because this height and then this height, that's got to add up to h. So, but I have a relationship. I have a relationship between the sides. I know that, you know, the bigger base is 3/2 or 1.5 times the base of the other one. So if that stands, all the sides are in that ratio 1.5 to 1. That would mean the height is in the ratio of 1.5 to 1. And a ratio of 3 to 2, remember when you do ratios, if the ratio is 3 to 2, a big key in the word ratio is you got to figure out the total parts, which you get by adding the two numbers. So there's 5 total pieces, so that must mean the bigger height is 3/5 height, and the smaller one is 2/5 height. You could say, that's really great, dude. Where's that going to get us? Well, let's see. This is 3/5 h, and this one is 2/5 h. So let's see if we can clean these up here. So we got 1/2 times y times 2/5 h. Right? If I multiply across, those 2's will just cancel out, and I should really just get what? YH over 5 is the area. But wait a minute. We have something here because we know YH is 70 over 3, right? So this is really equal to what? 70 over 3 divided by 5, which is the same as multiplying by a fifth. And that's going to give us 70 over 15, and we could probably clean that up a little bit. We could divide by 5. That's 14/3. Alright, so we're sort of getting somewhere. We know the area of AHF is 14 over 3. And we should be able to do the same for this one, for EHC. Let's see. So 1/2 times 3/2 times 3/5. We multiply across the top, right? 1 times 3 is 9. 2 times 2 is 4 times 5 is 20. So the area is 20 times y over h. Again, we know y over h is 70/3. So I do 9/20 times 70 over 3. Can I clean this up? Maybe that's a 1, that's a 3, the zeros will go away. So 3 times 7 is 21. That's 21/2. So now EHC is 21/2. So we're getting a little closer. I mean, we know, what do we know? We know that whole thing is 21 over 2, which is 10.5, so obviously it's going to be smaller than 10.5. If we could just figure out somehow another relationship where we could maybe take out a piece, like maybe if we could take this piece out, right? If the whole thing here is 21/2 and I'm able to take that chunk out, I'll be left with that. So now let's look at, see if we can know anything about this triangle. And now that we have these down, I'm just going to take away the work because we're running out of space here. Let's see. Let's clean this up a little bit. So now we want to try to look at triangle EJC and see if we can determine any relationship there. And if we can do that, we might have a fighting chance here. So let's see. I'll just dry it off. We're not very high tech here. So here we go. Okay, so now when I look at this triangle, EJC, I look for a vertical angle, right? I have this angle. Oh, these are the same, right? These two are the same. And now again, it looks like we're in business here because I have this angle and this angle, which are the same. So I'm just going to get a different color here, so it might be a little bit easier to see it. If I can find the pen, it would be in business. Let's see. As luck would have it, I cannot find the pen. I'll try to embolden it. Let's see. So it's going to be this, this, and this. Should be similar to this, this, and this, right? They're going to share this central angle. These are the same, which would make the other ones the same. All right, so let's do the same thing. Now we're going to use triangle AJG and say that's similar to triangle EJC. Let's try to get the areas. Okay, so AJG rather, it's going to be 1/2 times the base, which now this piece is what? 2y. And again, we're not sure of the height. We know it's just going to come straight down, but we're not exactly sure what that is. We're going to look at EJC. It's going to be 1/2. Well, the base is just x, but again, we're going to try and get it into y. Where's our relationship? X is 3/2 y. So the base is 3/2 y. Again, we're not quite sure of the height, but we do know, again, this height, and this height, it's got to add up to h. So again, we have to figure out the ratio of the sides. So you can see we have one side that's 2y. If you want to get it, if it's easier to see it, you can make that 4 halves y. And this one is 3 halves y. Right? So it looks like this one is obviously a little bit bigger. What's the relationship? It looks like it's, because they share a common denominator, it looks like it's 4 to 3. So the ratio is going to be 4 to 3. This one is going to be, if it's 4 pieces, this is 3 pieces. With a ratio, what do? We add the two numbers. So it looks like one height, the bigger height is 4/7 height. The smaller one is 3/7 height. So this is the bigger one, right? That's 4/7 h. This is 3/7 h. So now we're good there. I'm going to clean that up so we have a little more room to maneuver here. Let's see. I think we're getting close. We're getting close. Let's clean this up. 1/2 times 2, that's just going to go away. That's y. So it's going to be, the area is going to be 4/7 yh. We're in business. We know what yh is. That's 70 over 3. So 4 over 7 times 70 over 3. That'll be 1. That'll be 10. That's 40/3 is that area. We may need that. We may not. Let's see. Really, I want this area. That's the area I want. So let's see. Clean that up across. That's 9. 2 times 2 is 4. Times 7 is 28. It's 9/28 yh. But again, yh is 70 over 3. So that's 9 over 28 times 70 over 3. Right, that's 1. That's 3. I think I can take a 14 out of there. That's 2. That's 5. So that's 15 halves now. So this sucker is 15 halves. So we're looking good here. Let's look at it. So we know EHC. So bing, bing, bing. That whole thing is 21 halves, right? Well, now if this thing we figured out is 15 halves, voila, we got it. It's just got to be 21 halves minus 15 halves, which is 6 halves, and as everyone should know, bing bong, that is 3. There's your solution. Tough one, very tough one. I actually thought somebody might be able to get it. Nobody really got it. Somebody came pretty close. We're going to do another one. We're going to do another one with similar triangles. I'm going to post that in the office. I'll try to post that one today. You know, the bounty's still out there. It's still $50. Because nobody got this, we should up it. It's going to go to 60. So keep working. Keep doing your best. You can ask for help, but again, we don't want to cheat here. Just do your best. Try to solve them. Good luck next time.